All right. So they give us a graph here, and in this problem they reference the graph as G. So the graph is G. When they're talking about that, they mean like G of x is our function. So they want us to estimate what G of 4 is. What this is doing is asking you to look at the graph and go where the graph is 4, but that's for the x value. So G of 4, let's say x equals 4, we want to know what the function equals. And so on our graph, x is 4 is over here. So I have to go down on the graph to this spot. That's going to be where x equals 4. And my function will equal what? Negative 4?
Oh, wait, no.
-2. Oh, wait.
1, 2,
Oh,
3,
sorry.
right? Yeah, no.
I was in the wrong path.
Counting's hard.
Yeah, it really is.
So it says estimate the interval or intervals where G is constant. Constant, remember that constant in your life, they don't change. Where is it flat? You see it? I missed it the first time I was doing this.
At the very top.
At the very top. So what we'd say is it's flat, and we're going to talk about in terms of the x's. So I'm going to write this as an inequality from x is what to what?
-4 to -3.
So -4 to -3. It looks flat to me. So x in between -4 and -3, the function looks flat. So like just that little section up there. Obviously at the top of the hill, maybe it looks flat a few times, but unless it's like kind of more obvious, you don't have to worry about that. It says for what values of x is the function, so they're talking about the function now, in between -1 and 2. So what values of x is the function in between -1 and 2? -1 and 2. So we want to know when the function is negative. So this is the function up here. So -1 and 2 is like basically, let me grab a different color. Here to here. So what values of x would that be covered? By 2. So from 0, right? Or no, from here to here. Yeah, I want to go back to 0. So from 2 to 3-ish, maybe? So I guess 2.5 maybe, yeah. So like in between 2 and 3. Sorry, it was over that before, sorry. All right, true or false? G of -3 is less than G of 5. G of -3, what is that? G of -3.
4.
So that's 4 up there. Is that less than G of 5?
No.
No, that's -3. So this would be false. So being able to grab things off our graph. Then it asks us what the domain is of G. Remember, domain is the possible x values that make sense for this problem. So low to high are x values. What x values can be used in this problem? So the graph stops. It doesn't keep going on forever. So -4 all the way up to +5. So x values range from -4 all the way up to +5. The domain is always talking about the x values, which leads us into range. Range is the possible y values. So the possible y values that can happen. value is exactly what it sounds like. It's the very lowest value that an x, or that the function can equal. So the lowest a graph will end up being. So like on a parabola, it'd be at the vertex, it'd be at the very bottom of the graph. And the maximum is obviously the opposite, kind of the top of the hill. Now this graph actually has no maximum value. So a parabola would have no maximum because it would just keep going on forever. But if I have a different shape, so like, I mean if I use, trying to think of one that, I don't know, I'll just use an upside down parabola. I was trying to be unique, but we'll just stick to the maximum value is if the graph is, you know, like upside down or something like that. And that's if there's arrows, that those have no like minimum. If they have a point, that can be the stopping point. All right, so you give us kind of this crazy graph here. And he wants to find the range of values. Now the range is talking about the y values. So you're going to want to grab your graph, graphing device, whatever that happens to be.
Oh my gosh.
You guys are like, but you're like random lake fans, like together. You're two. And again, those of you guys who are playing with your calculators, you're gonna get, oh gosh, look at all the crazy things that are going on when I'm not looking. I wouldn't even know how to do that otherwise. And it's just a matter of playing with them. That's why I want you guys to bring something or be trying. I mean, if you're not on Decimos right now, if you're, you can just be working through this. This is not easy to do until you get really comfortable with it. Like even right now, like I said, I'm kind of clunky with it because of just not having like used it recently. All right. So I have my graph here, and they want the range of values. So what values of y make sense for this problem? Now, first of all, does this graph have a maximum or a minimum point? A minimum. It has a lowest point. So what is the lowest point for the function? So -3, it looks like down here. So the lowest this would go, -3 would be the lowest that function would go. And then the y values, will it ever stop? No, y could be 500. So our range in this case, it'd be basically everything greater than or equal to -3. So you could write it this way, or you could write f of x. That would be our range. So it's from -3 on to infinity. And that's because that one has a minimum point. Now this next one wants us to look at just a section of the graph. So it wants to use a particular interval and just talk about maximum or minimum values. And it says to estimate them. So we don't have to have them be perfect. But again, grab your whatever graphing utility you're using. zoom out on. Whoa. It's kind of an ugly one, it's like crazy. Now this one I might actually try to set up my window a little bit differently if it's helpful. Otherwise you might want to use the trace button on your calculator. We want to find, they want to go from -5 to 5, what's the maximum minimum points? Because technically there is no maximum or minimum points if we went all the way out to infinity, because they would go on forever. So I'd prefer to be able to set this up a little bit differently if I could, but I don't know if I'm able to on here. I'm not real good with the axis here. So from -5 to 5 on my graph, I don't know if it'll let me draw on this. So basically they want me to look through like this little section here. What's the maximum and minimum points? Estimates. So if you're able to trace on your graph, or if you're able to go, so like on decimals, it allows you to click those points. So in this case, based off of what I found, and like again, if you haven't done a little trace button, maybe try that. So the minimum point is like a -17.035, and the maximum is like 38.5. So we have a maximum and a minimum point for this graph if we're just looking at that little section. And again, it's just a matter of being comfortable and playing with those numbers. Or playing with your graph, you get used to it. So -17 point, let's go 17.04. For where the function is the highest, not the x values. It's kind of like the y values, where are those the highest.
How are we supposed to be like able to do that?
What's it?
Like how are we able to do that?
So you should be able, that's why I was trying to say the trace button. I wish I had like a calculator up here that I can show you. So if you hit trace, are you able to kind of follow the graph and like see
Yeah,
where-
like if I trace like it goes down.
and then when it starts going back up again, then you know you passed it. So go down, down, down. Now it starts going back up, so like -17.01 on yours. And there is a way to check for a max and min, and I will show you guys that. I just want more people to have calculators. I'll show you guys that. And then you're going to go the other way to check. And like I said, there is a way to check maxes and mins on your calculator, but I want to see that more if you guys bring them, if you guys can get a hold of them. All right, questions? All right, so guys, homework is listed here. I'll let you guys get going on that. Again, try playing through your calculator, ask questions when you need to.